In this video, let's use GitHub Actions to build a containerized Spring Boot application and then deploy it to Microsoft Azure when a pull request is merged to the main branch on GitHub Central Repository. This is what we plan to do. When a developer with push access to the repository merges a pull request into the main branch on GitHub, this event will trigger GitHub Actions to run a workflow defined in a script file to build and push a container image to the GitHub container registry, and then deploy it to the Microsoft Azure app service. Let's define such a workflow to build and deploy when a pull request is merged into the main branch of the repository. Before you move on, make sure you first log into your Azure portal. Second, pick a subscription. And third, install Azure CLI on your machine. Okay, let's set up Azure using Azure CLI. First, let's log in. In the Azure CLI, let's create something called resource group and call it Hogwarts resource group. And here is the command. Oh, by the way, you can find all the commands and instructions that I use in the description down below this video. Okay, so let's create a resource group and call it Hogwarts-resource-group. Okay, so the group is created. And in the Azure portal, if you click Resource Groups and refresh, as you can see, this Hogwarts-resource-group is created. So you can either use the Azure CLI, or if you prefer GUI or a user interface, you can create it here using this button. And for me, I prefer Azure CLI. Then what is a resource group? A resource group is a logical container that contains all the resources we need for a project. For example, Spring Boot application, databases, key vaults, and so on. So think of a resource group as a folder for resources used by a project. We're going to put all the resources into this resource group, Hogwarts-resource-group. Next, let's create an app service plan. This will take a while. Then what is the Azure App Service Plan? App Service Plan defines the compute tier for your web apps. Take a look at the SKU and size. And by the way, you can change that in the portal as well. So let's go to the portal, go to Home, and we can access App Service Plans. Refresh, and this is the plan we just created. And of course, you can create the service plan directly in this user interface. Let's click into this plan and see more details here. So as you can see, this is our pricing plan, it's B1. And in basic B1, here is the CPU, memory, remote storage, and so on and so forth. And this is how they charge you. And if you have more demanding workloads, and I would suggest you to look at the production level plans. Okay. Now, in the third step, let's create an Azure App Service, and we will use that to host our Spring Boot application. This will take a while. Then what is an Azure App Service? Azure App Service is an HTTP-based service for hosting web applications, RESTful APIs, and mobile backends. You can develop in your favorite language, for example, Java, .NET Core, Node.js, PHP, Ruby, and Python. Okay, as you can see, our Azure App Service is created successfully. The app service name is Hogwarts-Artifacts-Online, and here is the service plan. Here is the resource group that this web app belongs to, and the startup initial container image is Nginx. Later on, we're going to deploy our containerized Spring Boot image on it. If you don't like command line and the terminals, we can go to the Microsoft Azure portal and let's click App Services. And that's the service we just created. As you can see, it's running. So let's click into it. And this is the default domain that's given to us by Microsoft Azure. And we can either click this or click Browse. So wait a sec. Now remember, we have this Nginx image preloaded.
2,000 years later.
Finally, it's loaded. It's very slow. Maybe I should pay more to get a better plan. Okay. In the left navigation bar, there are many important features that you can use to monitor our Hogwarts artifacts online. So here is the deployment center. So we click here. Later on, in GitHub Actions, we'll actually set up our app to pull container images from the GitHub container registry, so Azure can host our Spring Boot application. Now here are the logs. Look at here, we just pulled the latest Nginx image and run the image. Later on, when we deploy our Spring Boot application, you can see logs here as well. Okay, down the list, we have something called Scale Up. Now, if our Hogwarts Artifacts Online becomes very, very popular and we got a lot of traffic, then it's time for me to upgrade my service plan to boost my hardware. You also can set a custom domain name for this application. Right now, our domain name is this one, provided by Microsoft Azure. All right. That's all for Microsoft Azure setup. Next, let's toggle over to IntelliJ and define a continuous deployment workflow that can deploy our Spring Boot application to Azure. All right, so first let's create a branch. Git branch, continuous deployment. Git switch continuous deployment. Then under .github workflows, let's create the second YAML file. And let's call this Azure-webapps-deploy.yaml. And here is the code. Paste. Wow, it's pretty long, right? The name of this workflow is called Build and Deploy a Container to an Azure Web App. And here we define an environment variable called Azure Web App name. It is Hogwarts-Artifacts-Online. Now remember the picture I showed you before. This workflow will be triggered when a pull request is merged into the main branch. And that is really equivalent to push something to the main branch. That's why the trigger here is push to main branch. We define 2 permissions here. Now let's take a look at the jobs. There are 2 jobs here, build and deploy. Let's look at the build first. In build, first we check out the repository, then set up JDK 17, then build with Maven. Please note that in this case, we skip all the tests. We just want the executable jar file. The next step is to set up Docker build X. Then we log into the GitHub container registry because that is where we're going to push our Spring Boot container image. Then we lowercase the repository name. Repository name must be lowercase. That's why we need this step. The last step in this build job is build and push container image to registry. So when the build job is done, our Spring Boot container image is available on the GitHub container registry. Oh, by the way, line 45 defines the tag of the image created. For example, in my case, this is the tag of the image created. Okay, now we're ready to deploy. Let me expand the deploy job. Recall that I said, by default, jobs are run in parallel. But here, line 51 says, deploy can only be run after the first job build is finished. So deploy needs build. So these 2 jobs will be executed one by one, not in parallel. There are only 2 steps in deploy job. The first one is lower the repo name. So we make sure the repository name is lowercase. The second step uses Azure/webapps-deploy action. This action is provided by Microsoft Azure to deploy the container image built in the first job to Microsoft Azure Cloud. Let's look at line 61, this publish-profile property. It looks like GitHub Actions is trying to retrieve a value from this secrets.azure web app publish profile. What is this? Recall that we just created a Microsoft Azure web app with the name Hogwarts-artifacts-online. So you can think of this Azure web app publish profile as the login credentials to that app. Then how do we set up this value? Let's go back to the Azure portal. Let's go to the Hogwarts Artifacts Online web service, click Overview, and then let's download the publish profile for this web app. Let's copy this, copy, and let's go to GitHub. We're going to save that publish profile in a secret on GitHub. Here is how I do it. So let's go to Settings, and go to Secrets and the Variables, and let's create a secret for Actions. Because this secret will be used by GitHub Actions to access Microsoft Azure as the login credentials. So let's create a new repository secret. Let's paste the secret here. And if you remember, that secret name is called Azure_web_app_publish_profile, all caps. Okay. Once that is done, click Add Secret. Now GitHub has access to our Hogwarts Online Azure Web App Service. Let's go back to IntelliJ. There's one more thing I want to point out in this script. Here, line 36 and line 37. Do we need to set up the GitHub token? No. What happened is that at the start of each workflow job, GitHub automatically creates a unique GitHub token secret to use in our workflow. And here, docker/login-action is using this token to authenticate so it can push the Spring Boot image to the GitHub container registry. The github.actor is the username of the user that triggered the initial workflow run. Let me reiterate line 45. The final name and tag of the built image would be ghcr.io/ the name of the repository, a unique hash code generated by GitHub, like this. You will see it once the image is generated. And there's one more change, then we're ready to go. So at this moment, our users, they access our application through port 8080. So let's go here. And we're going to change it to port 80, since port 80 is more convenient. So let's go to application.yaml right here. And down here, let's configure the server port. Server port to 80. Again, that is always a good practice. That means we also have to change the Docker file, because in Docker file, we expose 8080. And we can get rid of line 15. Okay, so just remember, we modified 2 places. In application.yaml, we add line 17 to line 18. And in Docker file, we removed line 15. All right, so let me close both. So git status. So here are the changes. Git add, git commit, add a GitHub Actions workflow to deploy merged pull requests to Azure. Okay. Then it's time to push, git push. All right. Let's toggle over to GitHub. All right. As you can see, the continuous -deployment branch is here. Now there are 2 workflows. Let's trigger the first one by open a pull request. Okay, as you can see, this is a change. We added Azure Web Apps deploy.yaml. And we changed Docker file. We also changed application.yaml. Okay, so create pull request. This will trigger the first workflow to build and test. So let's go to Actions. And here is the one that is running. Okay.
2,000 years later.
Okay, the first workflow is good. The build and test passed. Let's go back to the pull request and trigger the second workflow, which is to build and deploy to Microsoft Azure. All right, so all checks have passed. So that's for the new pull request. Now it's time to merge pull request. Remember, once I click merge pull request, confirm merge, this will trigger the second workflow. Build and deploy a container to an Azure web app. So that workflow. So confirm merge. All right, then let's go to Actions. Now this time, as you can see, this is the second workflow. Let's click here. And if I click inside, you will see that this workflow has 2 jobs, build and deploy. And we're doing this in sequential order. So let's look at build. Now this time it should be fast because we skip all the tests. Now remember, the goal here is to generate an executable jar, and then build an image for this jar file. This job basically containerizes our Spring Boot application. Okay, so it looks good. Okay, it looks good. So the build is almost down. The build is down. And then the deploy job starts. It's right here. Setup job, lowercase the repo name, and the final step is to deploy to Azure. Good, everything is down. Our deployment is finished. Let's go to Microsoft Azure to check. So let's go here. Let me close this. Let's go here and try to browse. Okay, so it is still Nginx. And let's try to access. Now remember, this time we don't have to use :8080 because we're using port 80. And since we're using port 80, we can leave it out. So just /API/v1/ if memory serves me right, artifacts. This API does not need login. Press enter. 404 not found. Let's go back to the app service. Let's go to Deployment Center and look at the logs. But as you can see here, all the registry settings are correct. Microsoft Azure is pulling our image from this registry. So let's go to logs and take a look. It takes time to download and start the image. Look at the last line here. Container Hogwarts Artifacts Online for site Hogwarts Artifacts Online initialized successfully and is ready to serve requests. Okay, let's try again. Great, we got response back from our Spring Boot application, but this time it's not from localhost. It's from a real website with this domain name. Of course, you can customize this domain name by purchasing one. Domain names are pretty cheap these days. So this is a demo for artifacts. Next, let's access wizards. Recall that accessing wizards needs login. It says full authentication is required to access this resource. That's good. But it seems like our code has a bug. Instead of returning code 500, this one should return code 401, and the message should be something like username and password are needed instead of just a server internal error occurs. So in the next video, let's fix this problem. Okay, here, how about access the root? Okay, so that's Nginx. Maybe here we can put a landing page. Then let's go back to IntelliJ and wrap up. Git switch to main. Okay. Right. Then git pull. All right, good. So now everything is up to date, synchronized. Excellent. One more thing. Let's go to GitHub. Go to code. Recall that the created Spring Boot container image is pushed to something called GitHub Container Registry. It is right there. Okay, so let's click here. As you can see, this is the image we created. And here says it has been downloaded twice. That's this package here. Anyone in the world can download this container image from GitHub Container Registry by using this command, docker pull, since GitHub Container Registry is a public container registry for hosting images. Of course, you can also make it private. Once you pulled this image onto your own machine, you can use this docker run command to start a container. In this video, I demonstrated how to deploy a containerized Spring Boot application to Microsoft Azure with GitHub Actions. In the future, I plan to make more videos to demo deployment on Amazon AWS, Heroku, and Google Cloud. Those are also very popular cloud platforms. The workflows are extremely similar. Since Spring Boot is so amenable to cloud-based deployment, you can freely consider other providers as well. In the next video, let's learn how to set up staging environments in Azure App Service. This is a highly recommended approach during deployment. See you there.